review. Anyway, that's what we're doing. We're going through a review today. We're going to finish up what we didn't get done last week, which is talking about air compressors. And then after that, we'll just fly through a review. We'll do a couple exercises, and hopefully I'll get you home before your kids go to bed.
Awesome.
I assume that's what you want.
Yes.
Okay.
Very much.
Sounds good.
So the exam is going to be all the way through chapter 10. If you notice that we didn't really officially cover 10, but we did because we got it in. It was about operators and that kind of stuff, and thermostats. And was it thermostats too? Anyway, we had kind of already done a lot of that. I'm trying to get a couple chapters ahead in our lectures, just so you know what you're reading when you do read it. So let's go through compressors. Starting next week, or it's actually starting this week, we will have official compressor without having to use this little bit. Yeah, hang on, let me do everything. That's kind of odd, this thing is just bam. All right, let's pass these out. You already got yours?
Yeah.
We have, I have got notified by several of your fellow students that they aren't going to be here because probably
11,000
and a couple of people are sick.
So this is what's on the board, Kay.
Is it automatic?
Okay, so we've touched on this a little bit. I'm going to go a little bit more into detail about the air compressor systems. As you know, air compressor, all the air compressors you're going to be dealing with are going to be reciprocating air compressors. You will have to identify when they're not. All systems have this in common. Most all systems have this in common. This is an older model. This is the one that has this standpipe right here. Is actually, it says a filter dryer. This is actually filled with straw. If you ever go to an older pneumatic system, if you ever take this piece apart, that's like a 2-inch or 1.5-inch pipe with a bell on each side. And what that does is it slows the air down coming out, and it runs through some straw, and the straw helps absorb it, and then wicks it out slowly over time. It's an old-time technology. It's what they used to use. All compressors have an intake filter, or should have an intake filter. All compressors should have a safety valve. This is very important. You need a safety valve before and after your pressure reducing valve. All have to have a safety valve. Otherwise, you end up with that disaster that you saw earlier or this month. Most all of the compressors are belt drive, although they don't have to be. Some of them you get these rotaries and these oilless compressors, and ones that sound really loud. I prefer the kind that go chunk, 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 not this kind that go wee. That's my preference.
Between oilless and
Oilless compressors don't use oil. They have Teflon rings, so they don't have a crankcase that have any oil in it. The beauty of that is you're not getting oil carryover into your system.
yeah, but they're loud.
The bad part is they're loud and they wear out faster. So if you can stand the loudness, they're not bad. They sell them for that purpose. But I don't prefer them. I prefer the old clunkers. As the air, okay, all of them have drain cocks of some kind or another. Most of them will have automatic drain valves. We'll talk about how to service those a little later. But, we saw what happens if you fill an air compressor up with water. It will explode on you at a certain point. Or the compressor will crap out on you as it can't compress anymore. And if you're lucky, the gaskets will explode or a fitting will leak or something like that instead of the whole thing going kablooey on you. Okay, you have, obviously you have gauges. You have something to turn on and off your compressor. If you look at the diagram I gave you, there's a little more detail. You have, I don't think I have that up here, do I? Okay, follow along on your diagram in front of you. Okay, so your air compressor starts and it goes through it. The intake air goes through an intake filter. Okay, the air compressor air goes out. The high pressure air goes out, and it's subject to the pressure relief valve. The pressure relief valve. After that, it goes over to a gauge. After that, it goes to a pre-filter. Usually, you have a pre-filter. Then you have a coalescing filter to get rid of any vaporized oil or oil droplets. They call that a coalescing oil filter, or the secondary filter. Then, most times we have a refrigerated air dryer with the bypass. Refrigerated air dryer is designed to get the moisture out of the air, and it does a pretty good job as well. Then after that, the air escapes or gets out of the refrigerated air dryer, goes into a pressure regulator, then you have another gauge, then you have another pressure relief valve. I would recommend, really studying this diagram. It comes in real handy. And then it goes off to your devices. In this case, it goes to a thermostat to an actuator. Every step of the way you have drains. You're trying to get the moisture out. Moisture will kill a system if you don't get it out. In this case, up here, it shows that the drain cock is down on the bottom of the tank. But we also have drains on the bottoms of each filter, as well as at the bottom of the refrigerated air dryer. They're very important you keep the drains clean, blow them out when you need to. There are filters. I don't know if this one has filters or not. Okay, yeah, we have a little filter. And next week, or the week after next, we'll get into the main compressor room over here. If nobody's ever seen a compressor up close and personal, you'll have 5 minutes to do that. We'll be able to see these things all in as you would probably see them in a commercial application. The only difference between this and the one over there that we have in the building is that it's a horizontal tank instead of a vertical tank. With regard to these relief valves, I set up this little compressor here, and you really can't see what I'm doing, but these things look like little bullets. Okay? So most of them look like a little bullet and have a little chain or a little ring at the end of the stem. And what they're designed to do is just pop up if the pressure gets too high. They have a particular sound to them. I'll run this up. I'll show you what it sounds like. Okay? So when you have a relief valve going, that's what they sound like. And I've never heard one that does not sound like that. Got a little poppet valve in there, and it just vibrates as the air escapes from it. These things are sized for the system. You can't have too little you don't want it too little of a relief valve. Just like a boiler relief valve, they have to be size big enough to handle the compressor output. Okay, that is one of the most important parts of the air compressor system is their relief valves. The safety relief valves both on the high side and low side. This particular one is a low side relief that I showed you, and that protects your pneumatic controls and your piping. The high side relief will protect your tank and your compressor and all that. And as we get into more maintenance stuff, we'll be talking about pressure switches and all that and how to take care of those. You've seen this before, typical system, air compressor, dryer, filter station, thermostat. I know I'm trying to go fast here, guys. I know. Oh, there it is, same thing. Okay. Last term, I erased all of all these descriptions, and one of my test questions was fill in the blanks. What are they? So I'm not saying I'm doing it this time, but I'm just saying that's what I did last time. Okay, so there's different kinds of compressors. The book talks about positive displacement and dynamic. Dynamic compressors are the centrifugals and the axial compressors. You'll never see those in this application, I don't think. Those are your centrifugals and your axial compressors that they use the air velocity basically to create pressure. The most ones you're going to see are the rotary and the reciprocating. And there's different styles of reciprocating and different styles of rotary, but the most part you're going to be getting this bad boy right here and the reciprocating compressor. And I'll bet you 80%, 90% of your, 95% of your compressors are going to be that. So if you are uncomfortable around, any of that, or you just wonder which one should you focus on, I would focus on reciprocating. Okay, we've been through here before. We're just covering it at the time we're supposed to cover it. We have reciprocating compressor, piston goes up and down, creates, it's a positive displacement compressor, it creates a suction, causes the suction air to come into the compressor, and then it pushes it out on the exhaust stroke. You have your screw compressor with vertical lobes, turning at fast speed, causing the air to push up, forward. This positive displacement is when you use, when you get pressure on each cycle. And these just show a vane compressor the same way. Okay, piston strokes down, piston strokes up. You've seen this before. It's just an internal. If you want to see it again, you can see it online. Yay! An example of a vane pump. These are kind of sometimes you see them as these kind of little guys down here. They just have these little vanes on springs that go, you know, just that as it spins, it captures the air in this pocket and just spins it around to a discharge. And they got, I don't know, 1, 2, 3, 4, 5, 6 wear points on it, plus the cylinder itself. Yeah, a screw compressor. You got the scroll compressor. I've never seen a scroll compressor in the pneumatic control field, but they say they're there, but I've never seen one. And that's how they work. And there's your axial, and there's your turbine. Okay. How's that for going fast? Going too fast?
No.
Okay. This is an example of a duplex compressor. They're fairly common. You have a compressor here, you have a compressor here, and then on the control systems you have either a lead leg or an alternating system. A lead leg system is when you designate one of those compressors to be the main compressor, the other one is the backup compressor. So when the main compressor goes, it goes chunk, 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 and shuts off at 100 pounds or 90 pounds. And then if there's a failure on that, then the other one comes in. Or if there's both of them are down at the same time, then perhaps both of them come on at the same time. Well, that's off.
Water system.
You heard that before? Okay, on a alternating system, it'd be more. You'd have more equipment than this. You'd have an alternating relay of some kind or an alternating relay package of some kind. That would cause one compressor to be on at one point, and the other compressor goes on the next cycle, and the other compressor. It's designed to even out the wear of both compressors. And if one of them fails, then the other one will still stay on. So lead leg and alternating are two distinctions that you'll need to know. When you see a compressor, here's your refrigerated air dryer, very typical refrigerated air dryer. Obviously you have your outtake. Here's your air filters. There's your sump. Most of these have oil sumps on them. And before you do anything, you turn it off. I was at a job, and we were working on the air compressor. The owner of the building comes up and talks to me, and he shuts the machine off. He had a little light switch there, and he shuts it off. And that's cool. And we started talking, and I was doing this. I was just, hey, look over here, look at that, and then that thing started right in my hand, right next to the pulley. Lost my finger. The switch was mounted upside down. And I was an idiot. I didn't double test it. The switch is mounted upside down, so down was really on, and on was really up. On was really off position. So, funny, it hurts worse now than it did when I first got it chopped off. I mean, it's been 12 years or something. Anyway, so I'm really big on this, right? And I'm really big on belt guards. If you have a building without belt guards, especially if you have children in the building, for goodness sakes, make sure you have belt guards on there. Okay, all air compressors have intake air filters. You have to have intake air filters on there to protect the cylinders and protect the air supply as well. So you get small particulate matter that might just pass through the valves, pass through the cylinder, and go out. There you go. But then it gets caught supposedly by the filters in your air delivery system. But you're also trying to keep the particles off the cylinder walls as well. One of the downfalls, as these things get plugged, it starts, the piston comes down and starts sucking harder and harder and harder, and sometimes they suck oil through the rings. Then you start slugging your compressor, you start getting oil out to your system. So you have to make sure that these things are monitored and cleaned regularly. They can be mounted on the machine itself, or they can also be mounted outdoors. If you've ever been into a room that has an air compressor, oftentimes that chunka can be irritating, especially if it's close to the office or something like that. You can buy mufflers for them. You can take the intake and pipe it outside. Sometimes you'll be next to a school or something, you'll hear that typical noise, but now the noise is out in the playground and not in the classroom or in the mechanical room next to the classroom. So air filters, all systems have air filters, and if they don't, then they don't have a good system. They may look like that. You have these little pancake tile, they think they call them hockey puck styles. This is like a regular air filter like you have in your car. Some of them get really big, some are really small. These are really common today on the smaller compressors. That's just an example of a location of one. It'd be on the side of this one. The guy is just twisting off the wing nut at the end and grabbing the air filter. Okay, all tanks have drains. This is a vertical receiver tank. This one has a petcock on it. There's a manual drain on it. Remember that that compressor we saw the movie? We lifted it up. They lifted it up.
Dumped 50 gallons of it.
Dumped 50 gallons of water onto the floor. That's because they didn't take care of that. The best way to take care of that is to make sure that it doesn't get forgotten. So you bring your pipe out, you pipe it out here, you get some get a good bypass and a auto drain.
I knew a guy who took that off and actually put his air fitting there.
Okay, yeah, well, let's talk about that.
All the crap
is the dirtiest
that's stuck
air.
in it.
This is the dirtiest air you're going to get.
All the crap in there.
Yeah, you don't want to put your air fitting there. Air fittings go in the center of the tank. So you can get it that way. There you go. They just brought it out and
Yeah, I don't know why they didn't do that to all of
they
them.
just brought it out the bottom of the tank and now it's not forgotten. Okay, in this case they put a hose on it. They probably drain it once a week into a drain somewhere. I'm not sure about your municipality, but nowadays you can't just take that oil and dump it into the drain because it does have oil particulates in it, and so you have to put it through a separator. And you get those at Pacific, compressor or Portland compressor or whatever.
Yeah.
It's just an oil drain separator. They're $100 and they'll last for a long time.
We actually built our own at Service Steel.
You can build your own. DEQ come by and take a look at you. They may have something to say about it, but you can build your own.
Yeah, they never did, but they had basically it was a little trough with 3 trays,
Yeah.
and the feed came in through the bottom. I think it was through the bottom. I'm trying to remember how it was built. Anyway,
So it had a cascade.
it would bubble. We had blowdowns, and every so often it would just, and it would bubble through the one, and then it would overflow into the next, and then overflow into the next, and then there was at the very end there was one of those rag oil sopping things, and then it went down the drain.
Yeah.
And so it caught all the oil.
The point is that you had to absorb it at the end of
Yeah.
that cascade that you had. So the point is to make sure that your oily water does not go down into the drain. It's against the law. It's not good for the environment. And if you're in the service business, you got another sale and some more maintenance to do. These are examples of automatic drains. This one is an automatic drain that you time. You set up the timer. You say, I want it to drain for 4 seconds every 30 minutes, or 2 seconds every 10 minutes, or whatever it is. Depends on the moisture content of the air. If your air compressor's in a boiler room and you got leaky steam and all that kind of stuff, you'll be draining that thing all day long. It's best to get your intake air away from that kind of condition. These are 2 examples of manual drain or automatic drains. They're the old float drain. This little float right here lifts up off a seat, allows the water to go through, and then after the seat seals, then the mechanism in there stops the air from pushing it out. This is the same thing as this, just a little different, has a different drain mechanism on the side of it. This one you can't manually drain. Well, you probably can't. This one you can. There's a little push button on the front of it that you pull by. All of these have their good points and bad points. This one, obviously, having it drain automatically, electrically, is awesome. It's really awesome. I guess the bad point is if it gets plugged up, you'll never know. It'll go. Actually, that's not true. You will know because it goes hisses when it goes. These right here, they have the nice thing about it. They have see-through bowls on them. I don't recommend see-through bowls. I recommend getting a bowl cover that still have some holes in it. You can see the water level. Yeah.
Do those, the one is the electronic one, that's automatic?
Yeah.
It has a valve, right, that would in
Most of them do have a little valve on the intake.
Well, because I have one that I think is going bad because there's always a constant air pressure coming into the drain.
Okay, yeah.
I just need to replace
That's a
it.
bad one.
That's a bad one. Yeah, I wouldn't try to rebuild it. They're $100. And is it a plug-in or is it hardwired?
I think it's plug-in.
Yeah, it's easy to replace that. That's another nice thing about it. These things, you just spin them off and, you got brand new. One of the things you may want to consider, and I know the manufacturers of these want you to do it as well, is put a Y strainer up in front of it. And that catches the big stuff that kills those valves, because what makes that situation happen is a piece of crap got underneath that seat, and now it's just blowing air. And probably etched the seat, and now it won't stop blowing air. So having a Y strainer in front of it, it adds more maintenance to your day, to your month, but it'll extend the life of this. It depends on how, if you get these at 5 cents a dozen, then what's the big deal? But a strainer will increase your maintenance, but it'll also increase the life of your machine. Filter stations, oftentimes you have more than one filter. You may have a pre-filter that grabs things at 25 microns and bigger. Then you may have another filter, coalescing filter, and there you go, you get the oil coalescing filter. Then you may have a desiccant to try to keep it dry. This is a different kind of oil or air and water filter there. Then you have your final filter. This is kind of like what we have over there, which is not really a filter in itself, but it is a filter regulator station. Real common to see this, real common to see this, not as common to see that. What you don't have here is your refrigerated air dryer. I still put one on. Anytime you have a system, a refrigerated air dryer is I would say it's almost mandatory, but you can get away without it. These are other kind of filter stations. Here you go. They have these little sleeve filters in here. You can see that this bad boy right here will just spin right off, as will this one. It pulls off and there's an oil ring up on top of that. What else we have? This is a coalescing filter. You can tell because it's got the red cushion on the outside of it. This is a 5 micron. This is probably a 25 micron. They're all, every few months, if you have a kind up here on this style, they have a flow indicator. As the flow gets restricted, the little thing will turn red and it goes, oh, we have a restricted filter in there. Otherwise, you just got to manually look at it and maybe just put it on a schedule. If you got a normal system, replacing them every year is not too much. A filter regulator, again, if you ever get a chance to look at the one over there. Again, regulators, without the filters on them, they take all kinds of different configurations. These are some of the smaller ones you might see. They also have filter regulator combo. They also have the relieving and non-relieving regulators. The relieving regulators are the ones where you'll say you set it to 20 pounds and you want to say, oh, I want to get it back down to 18. The regulator itself will relieve that pressure. On a non-relieving regulator, you turn it up to 20 pounds or 25 pounds, you go, oops, I want to get it back down. You got to wait for the system to get it back down because it doesn't relieve that pressure. I prefer relieving regulators, and since I prefer it, I think you should too. And there you go. These are the compressor relief valves. They come in all sizes and different configurations, but they all basically look like that. Different pipe threads and different sizes, different capacities. But they all, I get to see what it doesn't, have that little pull ring. And that pull ring comes in handy because you've got to test your compressor every once in a while. You grab a hold of that pull ring when it's under pressure and blow off the seat. If it doesn't seal, good thing you found one that before it failed on you. So on the low pressure side, do the same thing. Just pull that little pull ring. Like over here, you can play with it if you want. Just pull the pull ring and make sure that thing is not sealed. Every once in a while, you'll find one that just won't pull. You just saved, if you replace it, you just saved yourself an exploding compressor possibly. And it only takes 1 out of 10 years to ruin your life. If one of those goes, you'll never forget. I never had one go, but boy, I know people who say they regret not having tested those. Sometimes they leak. Oh, this is a good one. Sometimes they leak, and you know what the maintenance guy does?
Tapes them up or something.
He takes them off and puts a plug in. That happens way too often. It's almost like taking the TP valve off your water heater. You can't do that, guys. These tanks, especially the ones that are not ASME, and especially the older ones, you gotta have these.
Yeah, since watching that video, I'm thinking about putting straps around mine, so if it does blow, the strap catches it.
Well, then the end bells will go flying.
Well, that's okay. The end bells are facing a way that I don't care. It's the sides flying at me that I'm worried about.
Okay, close up, the same thing. If I was to say what's the most important part of an air compressor system, it'd be the safety valves. Okay. Another typical application, you got your single cylinder over here. Just pump it into a tank. No mystery. Pressure switches come in all sizes. This is a very typical one put out by Square D. Right here you have your intake. Over here you have your electrical connections. There's a single pole or a double pole switch that activates and deactivates based on the pressure setting. You have, like all pressure settings, you have yourself a set point and then you have a differential. Some of them are additive, some of them are subtractive, but they're all almost, some of them are adjustable and some of them are not as well. So you'll find them in the catalog. Square D has like 5 billion of them. You go there, which one should I take? Well, in our field, if you have one that goes up to 125 and you can control it at 90, 70 to 90 to 100, that's great. The more pressure you have, the more water you will wick out of the air. Okay, so that's one thing. But the more pressure you have, the more energy you use on each stroke of that compressor. It's a trade-off. It's up to you where you want to
You
go on
also
it.
don't need it that
And for each stroke becomes less effective because you're pushing up against higher and higher pressure. This guy right here is very important. This is called the unloader. I don't remember. Did the book get into unloaders?
I don't remember. I don't remember that. So
Let's talk about it real quick. Just in case you're wondering, my intention is to get through this by 8 o'clock, and then we start review for the rest. Okay, and so let's talk about unloaders. You have your compressor. Okay, here's the crank, let's say. And here's your rod, and here's your piston. I'm just such a lousy drawer. I flunked art in kindergarten and never forgave myself. Okay, here's the head of your compressor. Here's your suction and your discharge, and your suction is connected to, let's say, an air filter. Okay, so your air gets pushed in here and gets pushed out here, and the air comes out of here into your tank. Okay? So your air goes into your tank. But before it hits your tank, it goes through a check valve. Okay, the check valve can look like I have one. It can look like a regular old ball valve, or it can look like this. This is an inline check valve. You may have seen them in your compressors. Basically, the air goes in, and at the end of the stroke, as it pulses, close and open. It allows pressure in, but as soon as this stops pushing pressure down there, it closes it. Maybe you give a little popping sound, as it's cycling back and forth. Next to here, somewhere on your system, you'll have a little line that comes out to an unloader valve. This unloader valve is mechanically connected to your pressure switch. The pressure switch, as it closes, it closes this right here and doesn't allow this pressure in here to relieve. The idea of the unloader is to take the pressure off the head of the compressor for when it starts again. So, the compressor stops, we have no pressure here. The compressor starts, this thing starts. Our unloader valve is no longer open, so this unloader valve is closed. It allows full pressure through your check valve, and this goes until the cycle's over. Okay. Sometimes you'll hear a little hissing at your pressure switch. You're wondering what the heck's going on. Well, it's probably your unloader. It's likely not your pressure switch itself. It's probably the unloader. So there are different kinds also. Some of them don't have them on the. Less likely, you'll see a little check valve on the side of the check valve. The unloader on the side of the check valve. And it kind of works the same way, but it uses a little spring-loaded check valve on here. So when the thing stops, then this thing allows air to come back out. I prefer the mechanical way, frankly. It doesn't get plugged up as much as that one, right? So, any question on unloader? Okay. And the terminology is the same as compressor unloader, and it does the same thing. Sort of. It relieves the pressure on the head of the compressor. Okay. Different styles. This particular one is a double pole. And there's your unloader valve right here on this one. This one, I'm not sure where it's at, but they have a discharge on that one. Most compressors of our style will have drive belts. The drive belts, the drive motor has a pulley on it that wears out. They have pull that drives a drive belt that wears out and goes to a driven pulley that usually stays pretty good for many years. Drive belts can be the flat style, the A section, B section. Usually they're not, they're not small 3V belts. They get cracks on them. Everybody here know how to troubleshoot drive belts? Okay. It's not unlike anything else. Except, like, if you're an automotive guy, you don't want to, the temptation if you're an automotive guy is to string these things fiddle string tight. You don't want to do that on compressors. The bearings are not as beefy, and they don't handle that big stress, but they can handle some. Most all compressors will have oil sump on them. Most all of them have a way to check the oil. Some of them, you check the oil with a
That's
dip.
my compressor.
There you go.
I have a Senko 2000. That's what that is.
There you go. Did you send this over to me? So you check the crankcase oil. Without crankcase oil, the thing's going to start to get hot because it'll wear out the bearings. Everything's going to blow up on you. Most of them are just splash lubricated, which means that as the crankcase turns, there's a couple of little rings on the bottom of that are around the crankcase. And as it spins, it just flips oil up into the bearings and whatnot. They're just like you got your bearings, you got your journal, you got your crank, you got it's just pistons and rings and the whole bit. If you're going to use something like this in an HVAC system, I would fire you because this is not control rated.
What's interesting is on that picture, that's the unloader right there by his palm. That right there. That's
that looks
unloader.
That looks like it might be the unloader.
It is.
Okay.
That's the exact same one I have. And that guy, when it first starts, it takes a second so you can hear the pressure building.
Yeah.
And it starts hissing louder and louder, and then choom, shuts off completely when it gets enough pressure.
Yep, that's what they do. This guy is changing the oil in an air compressor. Usually you got to be kind of creative with funnels and buckets. Yeah.
How often do you change the oil? Is it so many hours? Or?
Manufacturers have their own, each one of them has their own thing. The general rule of thumb is twice a year, 2 to 4 times a year. On the smaller ones, maybe more, because you don't have as much oil. On the larger ones, may have more capacity to handle the crap. You change it. I mean, the bottom line is, if you have a moist system, you change it a lot more than if you have desert air. I can't hear you.
Because you're saying you go a moist system?
If
Because you're losing that oil?
No. If you like have a lot of moisture in the air, oil is pretty gets attracted to moisture. Another thing too is when you're changing the oil, you don't want to use. You can use. I don't recommend using synthetics. I'd use 20 weight non-detergent or 10 weight non-detergent. I wonder if that's the air compressor.
No, it's the water pipe. Look at the gauge.
Oh, okay.
Right there, you can see that thing, that needle. This building has horrible water hammer problems, amongst other things.
Okay, 20 weight non-detergent is pretty standard. 30 weight is okay. I would use non-detergent. Anybody know why? What's that? It doesn't create what? Heat? It has more to do with detergents keep particulate matter in suspension so the filter can get to it. And that's the job of the detergent, is to keep it so you can get rid of the darn stuff. Well, these things don't have oil filters. They just run and run and run. So if you had a detergent oil, then you'd keep all that detergent instead of prickling, what do you call it, precipitating out to the bottom of the crankcase. It'll stay in suspension in the oil and be like a little lapping compound inside of your cylinder walls and around your bearings and your end bearings and your journals and all that. So non-detergent is the way to go. If you start throwing oil, and you shouldn't, but if you do, you go to a higher grade, and that pretty soon you just got to schedule a compressor rebuild or replacement.
That means I need to change the oil in mine,
Yeah.
because I haven't done that.
There you go. Non-detergent 20 weight. You want to use single viscosity, non-detergent oils.
Do they use just standard motor oil for that? Because
You can.
I thought you were supposed to use just compressor oil for that.
Okay, so I've talked to 1,000 compressor guys, and they all have differing opinions about whether or not synthetics are good for control air applications. They have no problem with it for shop air, that kind of thing. But for controller, when you have to maintain a real low oil carryover, there's like some stuff about it. And some of them are like, yay. I mean, I've used synthetics before on the advice of the compressor guy. But then you hear another compressor guy. We're talking experts in the field, 30 years in the business. Oh, I never use that. Oh, I always use that. So what do? Well, I go to the old tried and true, and I got compressors out there that are 40 years old still running. So I'll go with what's what I know.
Okay.
I'm not philosophically against synthetics.
Well, I was just curious because, like, I see compressor oil. You can buy bottles of compressor oil.
Yes, you can get the RUS 427 or whatever, Campbell Hallsfield has one. They're kind of spendy. That's another reason why.
Well, that's why I asked.
They're $40 for a gallon of that stuff or whatever. So versus $1.20 or
About
$4.
$4.
Yeah. And 20 weight non-detergents, harder to find, easier to find in the country. Farmers like using it. Okay, so compressor run test time. This is one of the tests you want to do on your compressors. It's very simple. You take your total compressor on time and off time. Okay, and that is divided, or you take your compressor on time and divide it by the total cycle time. Okay? On your homework last week, a lot of you got this wrong. Okay? So, we may want to go through that. So, let's, I don't have any examples, but let's make one up. Let's say the compressor on time is 10 minutes. Okay? Let's say it's off for 10 minutes. So what's the total, what's the cycle run test time?
It's 50%.
What's that?
Sit on for 10 minutes.
Off for 10 minutes.
Okay, so 10 over 10 plus 10, so 10 over 20 times.
Right. It's 50%. Okay. If you had a compressor that ran 5 minutes, and the off time was 10 minutes, what's the run time? Or what's the run time? Percentage. What's the runtime percentage? 33, not 30, because 5 minutes is 1/3 of. Anyway, it's 33. The value of this is, over time, you'll be able to detect issues with your compressor. Let's say you get into a new job, or you just get a new compressor, and you start it up, and you see, oh, I have a 30%, 33% cycle rate time. That's great. Then you test it again a year later, and you've got a 50% cycle rate time. Well, what's going on? This is troubleshooting. What's going on?
You're either using more air, or your system is wearing out.
Exactly. And if you're using more air, if you discover that you're using more air, you got to find out why. Do you have more system? Do you have more components? Or do you have leaks? I've seen compressors, and you will too. You'll see compressors running 24 hours a day, 7 days a week, and they never shut off because they never attack the leaks in the system. You have to attack the leaks in your system, otherwise you'll wear this thing down really, really fast. And as you wear it down, the first thing it does as it wears down is start throwing oil into your system. So now you start throwing thermostats out. I've been in buildings where you take the thermostat off the wall, and I get splurged with oil and water because nobody took care of the air compressor. Oh, I've seen them taken off the wall and watch them spray for 10 minutes.
Wow. Bet you
Yeah.
that one was functioning well.
Well, not just that one. But there's I don't know, probably dozens I can remember. So paying attention to this will help stop that 10 years down the road, 5 years down the road. Okay. This, I think you should probably learn this. I think you should probably learn that. It's basically you take the runtime divided by the whole cycle time. Runtime versus the whole cycle. Starts per hour. Really simple. How many times does that compressor start an hour? Okay. That will also give you an indication if something's wrong or something's not right with your system. If you got 4 starts an hour, in February, but now all of a sudden you've got 20 starts an hour in June, something's wrong. Something's wrong. You've got leaky valves, you've got usage, you've got a compressor that's not pumping right. The book says, and I agree, that the manufacturer is 4 to 10 starts an hour. That's pretty common. Okay.
I would assume that lower is better.
Mostly. Yeah.
I mean, ideally, if you could get it down to maybe half a start an hour.
They time it for approximately 25% runtime.
Okay, so yeah.
So like
four
it's,
would be-
that's what they try to do, because they know that with that kind of cycle rate, you know, that everything will stay warm. You won't condense water into your crankcase and all that kind of stuff. And it's a trade-off between that and compressor wear. You know, if you oversize your compressor, it's you know, you end up with having 4-second start cycles. That's not good for you. Okay, we're going to run real quick through actuators. We've done this before. We have all kinds of different kinds of actuators. This is chapter 10. Is that right?
no.
Okay, so we've been ahead of the game on this, so we can do other stuff next time. My intention is to do lots of other stuff next time. Okay, different kinds of dampers. Parallel is the most common kind of damper. You got the opposed blade is actually very common as well. And then you got your various round dampers. Actuators, you guys, if you want to, you can play with more actuators, anytime you want over there with a squeeze bowl with the air compressor. Anybody have any questions about how valves work? Back over here, water or steam goes in, and if the plug is totally up, then it'll allow water to go through. As the plug goes down, seals it off, and the water stops. Various configurations for actuators. This particular one looks like a Howard or a Johnson. And there's a big, wide yoke that sits on top of the valve, and then you have a large spring, return spring, and a diaphragm, and a piston cup, all very common to all actuators. Okay, in your book, who cares? Different ways to flow through mixing valves and diverting valves. An important distinction is diverting valves have, okay, you guys tell me, what's the difference between a mixing valve and a diverting valve? These are the kind of little nuances in the book that I try to capture.
Wouldn't it be mixing mixes and diverting just simply diverts?
A mixing valve has 2 inputs, 1 output.
Yeah.
A diverting valve has 1 input and 2 outputs. A diverting valve sounds just like it sounds. You're taking an input and diverting it here or diverting it there. A mixing valve mixes the 2. Sometimes they look exactly the same, and I swear to God, some of them are exactly the same. Okay, different ways to do diverting valve applications and 3-way mixing valve applications. I'm not going to test any of this stuff. This is the stuff that your hydronics guys are going to talk about. If you want a copy of this, this is actually came from, I can't remember where I got it. Anyway, mixing valve, 2 inlet, 1 outlet. Diverting valve, 1 inlet, 2 outlets. I don't remember. Okay, so just, do you remember me talking about taking some of these actuators apart? This one right here, these black ones, we've got several of them over here. These things are notoriously hard to take apart. Okay, this is the shaft, this is the damper actuator. So I took this one apart. I took the cap off, and here's the cap right there. Let me show you the spring that went in there.
Holy crap.
If you were not prepared,
Wow.
if you were not prepared for this thing to come off, it will really hurt you. Okay? So these things are really got a lot of pressure behind them. But you got just, if you start figuring out how much force you have, though, this is like what is that, 4-inch diameter? And what's the square inches of 4-inch? Pi r squared. So what's the radius? 2 pi is 8. Squared is 64. All right?
Yeah, that sounds
64 square inches?
about right.
Is that right? So if you have 20 pounds per square inch, 20 pounds times 64, 1,000 pounds of potential pressure or force.
That's about right.
Yeah, I mean, you can lift an elephant's leg with this thing.
When it releases, yeah.
So there's a lot of force to be played with these. Yeah. Oh, okay. And they're dangerous. These return springs are dangerous.
Do they make a spring compressor for those?
They do. They make tools for it. What's that? Good, but I'm not gonna.
You need a spring compression tool.
You need a compression tool, and you need you know, yeah. And
You
you
ain't-
can make that thing, I mean, think about it. We used 2 fingers on those squeeze bulbs, and we can make that thing extend and overcome the force of that spring. So that's the nature of compounding or force with that per square inch. That's what they talk about in the first chapter. Cool beans, huh?
Yeah.
Okay. This
I
is
have
the
the
important
clamps
stuff
for the
about
car
this
springs.
in that chapter. This is the things that you guys have to learn. There we go. Things that will be on your test. How easy can this be, man? Review your homework, do the highlights, come to class. You'll do great in the class. Spring range. Can you test for spring range? What is the spring range?
When it starts moving to when it.
What's spring range shift and spring range overlap? Okay? Somebody volunteer what spring range shift is.
I don't remember that one. I remember range overlap in the spring range, but I don't remember the other one.
Okay, spring range shift is the spring range that changes under load. Sometimes an actuator of some kind will, the true spring range, as you, under load, will not be the same as it on the table. So you have, 50 pounds of pressure in the system, it's pressing up against that. You have an undersized actuator or one that's barely sized, right? So instead of your 3 to 7 pound spring range, you may have a 4 to 8 pound spring range. You need to take that into account as you're calibrating your systems, because it doesn't make sense to, well, if you don't do that, you'll end up with this. Spring range overlap. So if you have a system that's 3 to 7 and then let's say 8 to 13, but if that 3 to 7 is actually 3 to 9, you have an overlap where you're heating and cooling at the same time. So if you don't physically check your spring ranges under load, you may end up with that overlap and wondering why in the heck are they still complaining about being too hot or too cold? Well, that's probably the reason why.
Yeah, 'cause you don't have
Even though
any
your
dead zones.
the thermostats are working perfectly, they're calibrated to the T, the rest of your systems are working great, you just didn't check what it actually was doing. So spring range and spring range spring range shift is important. Okay, that'll be on your test. Now, what won't be on your test is that.
Holy crap.
That's calculating the CV. It's the flow rate through your valves based on the differential pressure of your outlets. There are classes here that used to teach this all the time, and you may get into it if you get into hydronics. Personally, I let the engineers take care of that.
Yeah, really. I'm just going to change
What
the
is
bad
that,
one for a new one.
What does the variable stand for? I mean, delta, E.
Oh, look in your book.
Well, delta P is the pressure differential.
Pressure differential between inlet and outlet. You have your size of your orifice. You have the flow rate. You have
What about 2A and G?
I don't know.
G is probably I don't know. Without the key, I have no clue.
I don't even think that was in your book.
It might
It
have
might
been.
be somewhere. Okay, take a break. 10 minutes. It is